Okay, yes, everything is getting recorded right now. Let me share the screen again. Yes. Admit, admit. Okay, 11 people, that's great. Almost half of the class is joined. Okay, one more minute, kids, and I will be giving the class, and I will start anyway admitting the other people. No problem if they get late. Remember that this is being recorded. Okay, can you hear me, kids? I allowed you to use the microphones right now. Let's check if you can hear me.
I
Please
hear
talk.
you.
Hello, Mateo, right?
Yes.
How are you? What about the others? Can you let me unmute all of you? Wilson, please talk. No, no one. Unmute everyone. You should be able to unmute your microphones that you do. You should do it like in this part, more or less. Let me. Okay, I can hear someone also, only Angela Cárdenas, Mateo. Only Mateo,
Hola,
right?
profe.
How are you? Okay, and admit Camila. And okay, let's start. Let's start. Remember the other people that this class is being recorded and... Ah, no. Sí, estoy diciendo algo es para decirle que no se escucha. Pero ya me escuchan, ¿cierto, Wilson? Okay, the chat.
Teacher, I don't know the others, but I hear you.
That's great. That's it. Everyone public. Everyone public. Hello. Okay, I am going to mute all of you. Yes, that's great. And now you can talk to me, and this will be a message directly to me. Only I am going to be able to see it. And
Teacher, I am Jorge Moreno.
how are you, Jorge?
Fine, thank you. And you?
Fine, fine, really fine. Okay, so let's actually start. And I am going to close all of your microphones so we can allow participants to unmute themselves. Yes, that's great. Okay. So, hello, kids. We are going to start our first class of this term. See, waiting room. Sorry, admit all. Yes. Once again. Okay, admit all. Sorry, is that the people is still getting inside this class? 12 participants. Okay, actually, let's start, and I will check in a moment if more people is getting it. So, okay, actually, if you see here in the Padlet, I've organized all of these. I am sharing the screen. Yes, I am sharing the screen. I organized all of these by classrooms. So in 6A, 6B, you are here. Wow. Yes, 6B, you are here. Here is organized by days. So here you can see day by day what we are going to do in the first and the second hour if we have. So today we are here. This first class is going to be this video conference, and after that you're going to develop an activity in Alex that it is already activated, but you should attend this class. If you ask me about the performances are here. Sorry, see waiting room, admit all. Yes, the performances are here in the Padlet. So here you can see a PDF file. So whenever you want to have a little time to copy them in your notebook, please do it, because we are not going to use that time here because I need to explain. The presentations that I am going to use in the class of today are here, prime numbers and composite numbers, and I will be uploading the presentations as we do the classes, okay? So whenever you need a presentation file, you're going to find it here in the Padlet, okay? Okay, let me check the chat if there is any problem. Participants chat. I don't see the chat. Chat. Yes, Wilson. Yes, that's perfect. No problems, right? So, okay, let's start with the presentation. And this is good because this is a topic that you already saw with me last year, but okay, what happened here? Sorry. Okay, prime numbers. Okay. Sorry. Okay, prime numbers. Okay, so we are going to review a little bit, but don't worry, because this is only for you to remember, and we are going to expand with more complex things than last year. So let's remember what is a whole number. Okay. Whole numbers are simply the numbers that you use to count. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For example, 1/2, which is a fraction, let me write with this. 1/2, is it a whole number or not? Let me unmute Wilson. Hello, Wilson. Talk, please.
I think no.
This is not a whole number because this is not, I mean, the whole numbers are the numbers that you learned to count. You don't use 1/2 to count. Okay, that's great. Let me mute you. And this person is Jorge, right? I can't. Okay. Mateo, can you talk, please, Mateo?
Hello.
Hello. Okay, let me write some numbers and let me see if you know what is a whole number. Let's start with 3, 0.5, root of 2, 1/3. Okay, Mateo, 3, is it a whole number? Please talk, Mateo.
Yes.
That's a whole number? Yes. 0.5, is it a whole number? Mateo. Okay, no. 0.5 is not a whole number. Square root of 2, is it a whole number? What do you think? Let me see.
Is
What? Can you talk again, please? Okay, let me try with Juan David. Hello, Juan David. What do you think about square root of 2? Is it a prime, a whole number or not? Juan David, can you hear me? Okay, no. Square root of 2 is not a whole number because square root of 2, this number, is
La-
actually,
so sí se escribe así, pero
what? Okay, it's all. Okay, square root of 2 is not a whole number because it is actually 1,4, 1 something. And this is not a number that you usually use to count. And the same with 1/3. Okay, those are whole numbers. Yes. Okay, and prime numbers. Let me see if, for example, Chala, please talk. Unmute audio and Chala, can you talk, please? Juan Andres. 5. Hello, how are you, Juan Andres?
fine, are you?
Fine, fine. Okay. Can you, oh, okay. Do you remember the definition of prime numbers?
No.
No? Do you remember the numbers that are prime?
So,
So tell me one prime number, please, Juan Andres.
5?
5 is a prime number? Yes, it is a prime number. Thank you, Juan Andres. And another one?
3?
What?
3?
3? Did you say 3?
Yes.
3 is a prime number? Yes, it is a prime number. Thank you, Chala. Because sorry. Yes, that's it. Because prime numbers is a whole number with exactly 2 factors, itself and 1. But what are the factors? Okay, so let's start checking. A factor is the number that if you multiply it, you get that number. For example, let me select the number 10. Number 10. It has some factors. If you multiply the 1 times something, does it get 10? 1 times something, is it 10? Yes, 1 times 10. So the 1 is a factor of 10. If you multiply the 2 times something, do you get 10? Yes. If you multiply the 2 times 5, you get a 10. So the 2 and the 5 are factors of 10. Let's try with the 3. 3 times something is 10. 3 times 2, 3 times 3, 3 times 4. No, you don't get 10 if you multiply the 3 times anyone, times anything. So the 3 is not a factor of 10. Let's try with 4. 4 times something is 10. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. So you don't get 10 if you multiply the 4 times anything. So the 4 is not a factor of 10. And we get again to 5 that we already know that is a factor of 10. So that's great. We finished because if we continue, we won't get anything else because we already got this one. So what factors of 10 do you get? You get, oh, sorry. Okay, one moment. Again. That's, sorry. I don't know what happened here. This is, okay. So once again, the factors of 10 that we found were 1, 2, 5, and also the 10 itself, because if you multiply 1 times 10, you get 10. So these are the factors of 10. There is nothing else. But a prime number is a number that only has 2 factors. Sorry. Yes, that's it. 1 and itself. That also means that a whole number cannot be made by multiplying other whole numbers. So for example, in the numbers that Chala said, they were 5 and 3. Okay. What are the factors of 5? 1 and 5. Is there any other factor of 5? Well, let's try with 2. 2 times something is 5? No. Let's try with 3. 3 times something is 5? No. Let's try it with 4. 4 times something is 5? No. And we get again to 5. So only these two numbers are the factors of 5. So how many do we have? We have 1 and 2. Only 2 factors. So the number 5 is a prime number. The same with 3. 1 times 3 is 3. So these two numbers are factors of 3. But if we try with the 2, 2 times something is 3? No. So the only 2 factors of 3 are 1 and 3. So it only has 2 factors. Therefore, it is a prime number. How many people is there? 20. Perfect. Almost everyone is here in this class. Okay. So that is the definition of a prime number. Again. So if we can make it by multiplying other two numbers, it is a composite number. For example, the 10 that we saw some moments ago. The 10 had some factors. It had 1, 2, 5, and the 10 itself. How many factors does the 10 have? It has 1, 2, 3, 4 factors. It's not a prime number because prime numbers only have 2, 1 and themselves. Okay, only itself and 1. 1 is not a prime number because it only has one factor, 1, which is the same than itself. So 1 is not a prime number. Okay, so here. How many apples do we have? 1, 2, 3, 4, 5, 6, 7. 7 is a prime number. Let me ask one of you. Okay, Juan Bautista is joining, user is joining, Samuel Arias. Hello, Samuel, you can talk. Samuel. Hello, Samuel.
Hello, teacher.
How are you?
Fine.
Okay. So how many apples do you see in the slide?
7.
7. What do you think? Is it a prime number or is not a prime number?
Yes.
Yes, you say that 7 is a prime number. Why?
Yes. Because 7 again can divide in 7 and 1.
And 1. And can you divide it by anything else?
No.
No, let's try. By 1. 1 times something is 7?
7.
Yes. So 1 and 7 are factors. Let's try with 2. 2 times something is 7?
No.
No. Times 3?
No.
4?
No.
5, 6?
No.
Yeah, that's it. That is why prime is sorry, 7 is a prime number. Thank you, Samuel. Where are you? Where are you? Where are you? Okay, you're already close. Thank you. Next slide. Can you divide it in groups of 2? No. So it means that you have one group of 2, one group of 2, and other group of 2. That is another way of checking if it is a prime number, thinking if you can make equal groups of a certain amount. If you cannot do a certain group of 2 or 3 or 4 or 5 or 6, that means that it cannot be divided by those numbers. Therefore, those numbers are not factors of the 7, and it means that it only has 1 and itself. So that is a prime number. No, we can't. Okay, another person. Sofia Villalobos. Hello, Sofia. You can talk right now.
Hello, teacher.
Hello. How many apples do you see there, Sophie?
7.
Once again? Ah, yes. Once again.
7.
And the same. Can we divide it in the groups of 3? No.
No.
So, because there is 1 left.
Yes.
And here are the same 7. Can we divide in groups of 7? Yes.
Yes. Because
You make 7 groups of 1. Okay. So, thank you, Sophie. Please close your microphone.
Ya voy, teacher, ya voy.
Okay. Prime numbers have exactly 2 factors. That is the same thing that we have been saying the whole class. Okay. Blue are prime numbers. And the gold are the factors. So here we can see a list of the prime numbers and why they are prime numbers. Okay, one more. Chicos, perdón, les hago un paréntesis. Les recomiendo, pues entiendo que es la primera vez y de pronto muchos no tenían Zoom, que es lo que imagino, pues porque ahora nos toca dar las clases por Zoom. Sí les recomiendo la llegada a tiempo, ¿vale? Igual yo entiendo que ahorita pues era la primera vez, de pronto estaban perdidos, así que pues no hay lío, pero para que de ahora en adelante no siga pasando que tenga que yo que estar admitiendo las personas durante el transcurso de la clase, porfa, les encargo llegar temprano. Bueno, volvemos. So, all of these numbers are prime. Why? Because they only have these 2 factors. For example, the 2 only has 1 and, sorry, the 2 only has 1 and 2. The 3 only has 1 and 3, 5 and 4, 5 and 1, 1 and 7. Yes. And the prime numbers are infinite, actually. After the 19, there are more prime numbers, like the 23, the 29, and you can continue. Obviously, you don't need to memorize all of them. And that is why here I made you a list of all of the prime numbers from 2 to 100. And are all of the numbers that you see in blue, 2, 3, 5, 7, 1, 11, 13, 17, 19, 23, 29. Other time, yes. And all of the numbers that you see in blue. Yes, quickly, quickly, quickly. $97. Okay, so let's do something. Do you remember how to make the prime factorization? Let me ask Mario. Oh, where is it? Sorry, I lost my waiting room. Admit all. Otra vez. And I don't see the chat. Okay, manage participants. Oh. Mateo Santiago Ramírez. Santiago Ramírez. Hello, Santiago. Can you talk? Santiago. Santiago, 5, 4, 3, 2, 1. Okay. His cousin. Sarita, how are you, Sara Matiz? Can you please talk? Sara? Oh, you can talk. Okay, no problem. Okay. Mario. Hello, Mario.
Hello.
How are you, Mario? Okay. Mario, let's talk about something. Do you remember the prime factorization? Do you remember how we did that?
No, no.
Do you remember, for example, that we had, let's say, the number 30, 35, no, 30, 40. Okay, let's say the number 40. And do you remember that we had a long line and we started putting numbers on this side and on this side? Do you remember something like that?
Yes.
Okay.
Yes.
And what kind of numbers did we put there? Because here, remember that you only were able to put some numbers. What numbers were there?
The prime numbers.
Yes, that's it. Exactly. The prime numbers, that is why it's called the prime factorization, or also prime factor decomposition, which is the same thing. So we have to start by some prime numbers. So by what prime number? What is the first prime number? Here you can see them, Mario. What is it?
2.
2. So can you divide the 40 times by 2?
Yes.
Yes, one moment. Prime factorization. Okay, close factorization. Yes, so we can put the 2 here. And what is 40 divided by 2, Mario?
20.
20. That's it. Can you continue using the 2, Mario?
Yes.
Okay, and what is 20 divided by 2?
10.
10. Okay. Can you continue using the 2?
Yes.
2. And what is the result?
5.
Great. And can you continue using the 2?
No.
Okay, so now the 2 is useless. We cannot use the 2 anymore. Can you use the 3?
No.
Okay, so let's move to the next prime number. Not 4, 5. Can you use the 5?
Yes.
Okay. And what is the result, Mario?
1.
And can you continue, or are we done? Did we finish?
Finished.
Okay. So with this process, what we can say is that all of these numbers in a multiplication, 2 times 2 times 2 times 5, that is actually 40. Let's prove it. What is 2 times 2, Mario?
2 times 2, 4.
Okay, and what is that times 2?
8,
8. And what is 8 times 5?
40.
That's great, 40. So you can do this with every single number. That is a property of every number. Every number can be decomposed in only a multiplication of prime numbers. By the way, you can also write this like 2 to the power of 3 times 5 to make it shorter. It's the same thing. Remember, this is 2 to the power of 3. It's the same thing. Okay, and you may say, teacher, yes, you can do that. That is quite simple. It's not it's not difficult, but what does it work for? Why is it important? Why do we do that? Okay, let me close my Mario. Can you please close your microphone? I am going to give the word to other person.
Okay.
Thank you. And let's say Sofia, Valentina, Wilson. Now, can you talk? Hello, Wilson.
Teacher, I can hear you.
¿Sí me oyes, Wilson? Hello. Let me see. Stop video. Stop. ¿Me oyes o no me oyes, Wilson? Let me check the chat.
Yes, teacher, I
Okay.
hear you.
Okay, Wilson. Do you remember why did we use prime factorization last year?
Yes.
What did we use it for?
Um, to practice exponents?
Kind of.
No,
we use it
I don't remember.
we use it in order to find, for example, let's say cubic root of 8, the same example that I always used. We use it for that, but that is not the only. We made the prime factorization. We made, okay, 2, 2, 1, huh? And we made 3 equal groups. So 1 group, 2 groups, 3 groups. Every single group has 2, so the answer was 2. We did it for that, but that is not the only useful thing that we can use the prime factorization for. But we will actually see that in the other classes. So actually, let me check how much time have we been recording this class. I am going to stop recording the screen for a moment. Recording, I don't stop recording. Oh, 30 minutes, perfect. So we have some more minutes before the session of Zoom finishes, because you know it always finishes at 40 minutes. Thank you, Wilson. Now, let me share the screen again. So now let's talk about something which is related, but it's not the same, which is composite numbers. And you may say, teacher, what is composite numbers? We didn't talk about that before. That is something new. And yes, that is something new, but I can assure you that that is not actually anything difficult, because a composite number is, okay, let's read it. If a whole number is greater than 1, and it's not prime, it must be a composite. So what does that mean? It means that the composite numbers are every single number that is not prime and that is not 1. So what numbers can be multiplied together to give me 2? Yes, that is
1.
a prime number, 1 and 2. You're still open, Wilson, right?
Sí.
Can you please close your microphone? Thank you. Okay, so besides 2, which is the only prime number, every single even number, remember, even means par, números pares, and odd numbers are números impares. So 2 is the only even number that is prime. But besides, every other number that is even is a composite number because they are not prime. One. Okay. Let's practice. Okay. What do you think? 5 is a prime number? Let me select another person. Manage participants. Simon. Hello, Simon. Can you talk, please? Hello, I can hear you, Simon. Please talk.
Hello.
How are you, Simon? Okay. Let's practice with you. Prime, is it composite or, sorry, 5, is it composite or is it prime? Hello, Simon. Simon, 5, 4, 3. What happened, Simon? 2. I cannot unmute it. So another person, Chala. Okay, Juanes is still joining. Juanes, are you there? Ah, no, este es Juan David. Ah, no, este es Juanes. Juanes, how are you? Juan Esteban Bautista, hello. Please talk.
Teacher
How are you, Juanes? Okay, let's practice with you.
is prime. It's a
It's
prime
prime
number.
number. Okay. 88.
Is a composite number.
That is a composite number. It's easy. It's even, so it must be composite. But what about another number, 27? Is it prime or is it composite?
It is prime.
Okay, it is prime. So you say that only 1 and 27 are the factors of 27, right?
Yes.
Okay, let's check. So 1 times something is 27. One is?
For 27.
Yes, 27. So 1 and 27 are factors of 27. Let's try with the 2. 2 times something is 27.
No.
No, so 2 is not a factor of 27. What about 3? 3 times something is 27?
No.
No, what about 9, Juanes? 3
Oh.
times 9 is not 27?
Oh, yes, yes, yes.
Okay, so 3 and 9 are also factors of 27.
It's
Okay,
not,
let's try
it's
with
a
more.
composite.
It's not composite. It is, no, sorry, it's not prime. It is composite. You understand the difference, right? One is?
Hello.
Hello.
Yeah. Yes, yes.
Okay, but actually, let's try to find more factors of 27. 10. Sorry, 10 no, 4. 4 times something is 27?
Mm, 27. Mm, No,
No, so 4 is not. 5?
no,
No. 6?
no,
No. 7?
no,
No. 8? No. And we get to 9, but the 9 was already there. So we already found 9. That means that we finished because there is not going to be anything else. So the factors of 27 are 1, 27, 3, and 9. Okay? So 27 is not a prime number. Let's check the next one. Juanes, 8 is prime or composite?
composite,
That's great. 75.
Composite.
That's right, composite. Let me give you an advice to all of you. If the number is even, this one is not even, no? Este no es par. If the number is even, it means it's not prime. It's composite. If it finishes in 5, it is composite because that means that that is a multiple of 5. So if it finishes in 5, 0, that is a composite. Because it means that we can divide this number by 5. And that will be, what is 75 divided by 5? It will be 25. No, actually, no, that is not 25. It will be 3. Yes, 3. So it means that 5 and 3 are also factors of 75. And we can find all of the factors of 75, but let's not do it. Let's actually move to the next one. One is 66.
It is a composite number.
Yes, it is a composite number because it finishes in 6, what means that it is an even number. So thank you, Juanes. Let me once again check if the session is going to close. I think it's going to close really, really soon. Yes, it is going to close soon. So kids, let me ask you, if the session closes automatically in some minutes, you know that you have to solve right now an activity that is activated on Alex. If you have any question, I will be checking videos all of the time. So you can ask me, and if you have a serious doubt, we can actually make a meeting through Zoom also. So kids, thank you very much. I am going to keep explaining or to keep practicing. I am going to select Mario ya, Samuel ya, Santiago no, Simón, Valentina. Hello, Valentina, how are you?
Hi, teacher.
How are you? Let me see if there is more things to practice. Yes. Valentina, what do you think about the number 2? It is prime or is it composite?
Prime.
Yes, that is the only even prime number. That's great. What about the 99? Is it prime or is it composite, Valentina?
Prime.
So you say that the 99 is prime because on the only factors of 99 are
Composite.
is composite? Okay. Why did you find it?
Because 9 times 11 is 99.
That's great. So the 9 is also a factor of 99. It means that 99 is composite because it has more factors. Okay, one more. 30. Is it prime or composite, Valentina?
Composite.
That's great because it's even. It finishes in 0. It is even, and it also is multiple of 5. Next one. 11, Valentina. Prime or composite?
Prime.
Yes, that's a prime number. And that is actually the end of this presentation, kids. So remember, all of the presentations are here in the Padlet. So here are the performances of this term. This is the presentation of prime numbers, the presentation of composite numbers. When this recording is finally uploaded in YouTube in some minutes, I will send the link to you through video so you can review it whenever you want. And right now, you must go to the platform Alex and please solve an activity that I created to you. And remember, if you have any question, you can ask me through videos. I will be checking. So thank you very much, kids. I am going to unmute all of you. Chicos, ¿tienen alguna pregunta final antes de cerrar la clase? Y que se pongan a hacer su trabajo de Alex. Todos pueden hablar en este momento.
¿Hay alguien? Sí, profe.
¿Preguntas?
¿Qué tal que no podamos hacer el
No.
trabajo de Alex ya que tenemos alguna otra actividad pendiente en otra clase?
Pero chicos, en este momento el horario dice, miren, de hecho puso mi horario. Ok. De hecho puse mi horario. ¿Dónde tengo aquí el horario? Dios mío.
Pues Mateo, tenemos 2 horas de math.
Tenemos 2 horas de mat. Esa es la cuestión, Mateo. O sea, tú tienes mat
eh,
hasta las 9:30.
y después descanso. Y después si tiene trabajo de inglés, pues lo hace en la hora de inglés o lo hace
Gracias,
en el
Wilson. Sí,
descanso.
señor. Muy cierto. ¿Alguna otra pregunta, chicos, antes de cerrar la clase?
Bueno, chao,
Parece que
profe.
no. Chao, Wilson. Cualquier pregunta me escriben por Fidelidad. ¿Listo, chicos?
Listo.
Los voy a cerrar, los
Ok.
voy a sacar a todos, ¿vale? Chao.
Bueno.
A ver, ¿dónde está esto?